Hello，大家好，欢迎来到本期的纯银时刻。那本期的纯银时刻，我们在 TS2025上海国际音响展的现场。那这次展会，有两大幸事，一是非常有幸邀请到了来自英国 Wilson Benesch 金池的创始人 Craig， 同时呢，他们的旗舰黑胶唱盘 GMT1 也是首次在上海开声。那这次的盛会，我们也是带来了全套的阵容。也趁此机会，我们一同向 Craig 了解一下这一套超级黑胶旗舰的这样一些技术细节，包括他们的研发理念。Hi Craig, it's very nice to have you here in the TS 2025, and it's the first time we show GMT1 in Shanghai.
Yep, first time.
Yes.
We should have been here before, earlier, but things didn't go as quickly as we thought.
And we bring a super system here.
Yes.
And I think many audiophiles want to know more about GMT1.
GMT1 is a very, very long-running project. It's been worked on for more than 15 years, and we've tried to bring something completely new to the market, which is significantly different from anything that's been done before.
And there are a lot of secrets.
Secrets, you could say it as a secret. That there is patents. There are a number of items in the design that are patented, not only by ourselves but by the companies that we've derived technologies from, including the pneumatic system and the chuck system on the tonal.
Yes, I have a lot of questions from our audiophiles, also from myself.
Sure.
And the first question is about the Alpha Drive.
Alpha Drive.
And the Omega Drive.
Yeah, the classic motor is designed to be extremely efficient, and that means that the magnets and the coils are very close to each other, the stator and the rotor. This is not a classic design motor. It is completely different. It's designed for one thing, and that is to play a record with the lowest noise. So we had to create a completely different drive to make it work, which had never been done before.
And I know it's the biggest direct drive motor in the turntable.
That's right. The original design kicked off with a magnetically geared motor design, which was based on a diameter of this size. And that technology did not prove to provide the results. We spent over 2 years working on it. And so when funding was won, we created a team with another SME and the university in our town. And we did a project which took that technology and created a synchronous motor from it. So we created a completely new technology from it.
Yes, I know there is two ways to drive the platter. One is the direct drive and another is the belt.
That's right.
How do you think about this two?
Well, the belt drive will always change over time. It will always be subject to variation. It's very easy to create a turntable with a belt drive. Direct drives to date have typically been based on Technics motors, which are very, very high torque. And although they address to some extent the cogging aspects that are related to high torque motors, it's a different market to the market that this product is aimed at, which is to try and get complete zero noise, and we've achieved that due to the 4 Hz drive frequency.
Yes, it looks like art.
The looks are directly related to physical challenges relating to the way the product sounds. We weren't trying to design something that was aesthetically tantalizing, and like all good engineering, when it looks right, it generally is right. So my view is that something that is actually good at what it does always looks beautiful.
Yes. And another question about, I noticed that there's two things in the GMT1 afloat. One is the plant and another one is the platform.
This is true, yeah.
Yes, I want to know more about the level.
So the planet is vibrating and there's a lot of noise in the ground, and you have got to try to measure meter deviations in a piece of vinyl if it's moving in any way, then that ability to measure that nanometer scale of data is impossible. So the only way you can achieve that is by, that's perfect timing, did you see that? Is by isolating it with a pneumatic system that is taken from the laboratory where microscopes are mounted on these kind of systems. Because obviously when you're looking at something with microscopes, you need to isolate the environment, and it's exactly the same technology.
Yes, and I know there are a lot of turntables, they are float. And what's the difference between the level and
the level is a computer-controlled, pneumatically driven system which is taken from an established company that has developed this science for the laboratory environment. So we're not trying to reinvent the wheel. We've taken technologies that are demonstrably known to function in a laboratory situation and transferred it simply into our turntable. We haven't tried to create something that is radically different because it already exists.
So it's very precision and better control.
It's a computer control system which basically monitors the whole system constantly, and if there's any deviation it adjusts and makes the change automatically, so you don't have to worry about it, and it doesn't change over time, so it's very reliable.
And the third question is about the tone arm. I know your first product is also the tone arm, and now you have the super new one.
This new tone arm is a very, very significant development, and is already being adopted by other manufacturers who have got turntables without tone arms. The critical thing in this tone arm is of course the carbon fiber, but another important development is the titanium. Titanium, as you know, is extensively used in aerospace and aircraft. It's used in the landing gear, it's used in the engines, it's used in everywhere where you need maximum strength with the lowest mass.
Yes.
And titanium is the only material which can create this kind of structure. We selectively laser sinter the titanium to get the material in exactly the right place and nowhere else. So with selective laser sintering, the material that is melted is the material that you require and nothing more. This in engineering, this is called zero redundancy. You cannot get this kind of engineered part with a conventional CNC machining. You can only create this with selective laser sintering. And this is done with 5 laser beams that literally melt the titanium and fuse it to adjacent particles. So in this case, this is solid, but this is not. This is tessellated inside. And in the part that fits over the front here, this is actually hollow. So you can do things with this technology that is impossible with conventional manufacturing.
And I know you also use the maybe similar technology
in the cartridge.
Yes.
The cartridge is a critical part, and what we've tried to do is not only create a cartridge with a cantilever that is quite different, but also the diamagnetic properties of the titanium also lend themselves to the housing for the cartridge. But what we're trying to do with the cartridge is also add a fin to the end of the tone arm, and the two, when combined, create a very highly damped and very stiff structure. We actually bond the cartridge to the head shell when we set up the cartridge, so when it's supplied to the customer, the cartridge is already perfectly set up for use. So it takes away all the issues with regards to accuracy of setup, which is absolutely critical when you're dealing with the kind of infinitesimal small degrees of measurement that need to be done. But the titanium, of course, at the cartridge end is ideal for the stiffness to weight ratio. And the cantilever, we've also created a completely different cantilever to anything that's been done before, because we have a UD carbon tube on the cantilever, which transforms the stiffness to weight ratio of the cantilever. So there's a whole range of different things that have never been done before.
Yes, I think this time the GMT will create fantastic things, not only a turntable, the tone arm, and the cartridge.
It's an entire system.
An art, I think.
It's like a Formula One car.
Yeah.
You have to make small incremental improvements in all the different systems and bring it all together to make that performance step forward that is impossible otherwise, because it only needs one element and the whole thing can fall apart, and that is something we want to take out of the equation.
Yes, actually, I studied about your explanation to the GMT1 on YouTube last year in Guangzhou.
Okay.
This time, maybe the third or fourth time, I listened to your explanation of the GMT1. I still feel it's fantastic things, something.
Thank you. I think there's something else that is for me very important, which I'd like to say is that the system is called a system because it is comprised of multiple designs. And this was a big challenge in the development of this product.
Thank you, Craig.
My pleasure.
I think everybody likes your explanation to the GMT1.
We've only touched upon the surface, but thank you for your time, Clay. I appreciate Purist Audio for making this possible.
好，那我们本期的纯音时刻在 TAS 2025的现场对 Wilson Benesch 的创始人 Craig 的采访就到这里。那后续我们也会带 GMT1 这套超级黑胶系统来到更多的城市，带给更多的发烧友来聆听。欢迎大家继续的关注，感谢大家，让我们下期再见，拜拜，
拜拜。